Section 9.3, Confidence and Prediction Intervals, Video 3. So let's get down to it. Here's the formulas for calculating both the confidence interval for a mean response in a simple regression and a prediction interval for all responses in a simple regression. So let's suppose you have a simple regression, y hat equals b0 plus b1 times x, and a specific predictor value x star. To calculate the confidence interval, it's just a confidence interval and it has the same 4 steps. For the first step, we're going to find the value of t based off of the confidence level, and the degrees of freedom will be n minus 2, where n is the number of ordered pairs that we have. And then we'll find a standard error, and we'll get to that mess in a minute. But once we find the standard error, just multiply the t times the standard error to get your margin of error, and then find the interval, y hat plus or minus the margin of error. The way you calculate the y hat around which you center the interval is you just substitute the specific value for the predictor, x star, into your regression equation, and then calculate the value of y hat. Let's go back to the standard error formula for a second, and then we'll look at the prediction interval formulas. The standard error formula is kind of junky and contains a lot of pieces. It starts out with the standard deviation of errors, which we had called S sub epsilon previously. And recall that the formula for S sub epsilon was just the square root of MSE from the ANOVA table. So right away we're going to need some information from the ANOVA table. In fact, I should probably make a note here to remind you that this is from the ANOVA table. But that's just what we multiply outside the square root. On the inside of the square root is a lot of stuff also. The n is still just the number of ordered pairs, so we start with 1 over n, plus another fraction. On the top of the fraction, we have x star minus x bar, and that difference is squared. The x bar is just the average of all the observed explanatory values. So for example, on the scatter plot with the bills versus the tips, we would take all the bill values that we observed, average them, and that would be the x bar. Now, you won't have to calculate the x bar because you'll be given what are called the summary statistics for the data set. So for the bills, here's how many bills there were, what their average was, and what their standard deviation was, and the same thing for the tips. So this x bar represents the average of all the observed x values. In the denominator, we have n minus 1, which is just the number of ordered pairs, minus 1. But we also have the square of s sub x. In other words, the square of the, and I'm saying standard deviation because it is, the square of the sample standard deviation of the observed explanatory values. This is also the variance, but let's just go ahead and call it standard deviation squared. So this is where it slows down. You got a big mess here, a lot of values to put in, and you have to get them from a lot of places. The standard deviation of errors, from the square root of MSE from the ANOVA table, and from your summary statistics, you'll need the mean and standard deviation of all the observed explanatory values. But if you can get past the standard error, then the rest of it is pretty straightforward. Just remember at the end that you create the interval centered at the predicted response value, in the example, the predicted tip, when the explanatory value is a certain value, in the example, when the bill was $30. For a prediction interval, you do almost exactly the same thing. And you have to look really closely to see the difference between the two. I'll give you a hint. It's in the standard error formula. Do you see it? The only difference between the standard error formula for the confidence interval for a mean response versus the prediction interval for all responses is under the square root, there's a 1 plus. Everything else is the same. That 1 plus doesn't make a whole lot of difference, but here's the impact it has. As a consequence of this 1 added under the square root, the value of the square root is slightly larger than the value of the square root over there, which means the standard error is slightly larger than it is over here, which means the margin of error is slightly larger than it is over here, which means the interval is slightly wider than it is over here. So as a consequence of this 1 plus, your prediction interval will always be wider than your confidence interval. In the next video, I'm going to put up the summary statistics, the ANOVA table, and the regression for the bills and the tips. And then we're gonna manually calculate the confidence interval and prediction interval and see if we got the same one that was listed on the board previously, which I had taken out of the book.